Recording now. Do you want to say that again?
No.
So what was your question? Related to the content of today's lesson.
What is get and set?
What is get and set? Can someone tell me what get and set have been like in past times that we've used them? Jack. Jack. Do you want to tell us about get and set? Six-word story, get and set. Ha ha ha.
I don't know what
I don't know what they
they
are. Okay. Thanks so much, Mike. Sunny, can you tell me about get and set?
How we used it before was we were able to change or compute a different value for another property in the same
Yeah,
data structure.
that makes sense to me. So, on the highest level though, what is get and what is set? Who's it gonna be? What do they do? So, cool. So get reads the property, set writes the property. We've seen in the past with a computed property that we define how we get and set them. In a protocol, what we define is not how we get the property, but instead think of it like the permission that the property has. So the poisonous bool here cannot be set. You can only read what it is. So the protocol is outlining there's gonna be, for anything that conforms to my protocol, for anything that conforms to my protocol, so anything that uses this template to add some behavior and properties, for the thing called poisonous, you are only going to be able to get the property. You're not going to be able to change it later on. Yes?
So what for shape,
Shape.
as in like I saw you input in shape when you were initializing it. So how does that work?
So I initialized it because it needs a value for it, just like we've seen with structs in classes before. So it will need a value. But once that value is set, think of it like a constant. So read-only property is kind of like a constant. You can only get the value. Iram.
One example of a get-only property that we were just talking about, you've seen in Swift is like we have an array, and its count property is actually a get-only property. Because you can't say my array.count is now equal to 8 or whatever. You can only read the count of the array.
Cool.
Ben just talked about it.
What?
Ben just talked about that to us.
Oh, thanks, Ben. He's never here when I need him. He's never here when I need him. How's that for an example?
Yeah.
Okay.
Wait, so you get instead again act like permissions, right? So
Yeah. What you're saying in the protocol is what that property is allowed to do. Then, when you create some sort of type that conforms to your protocol, you're saying exactly how that property is going to get a value and potentially how you can change that value. If it's get only, you'll only give it a value once. Think like in a class, you'd have an init function, and we've seen similarly a struct just by its nature says, oh, you haven't given me these values, so initialize me with these values these properties I don't have yet.
So if we were to call it SFL, SFLS dot consistency and try to get a new value, it's not gonna go, right?
Let's try it. Then Nima, hang on one sec. Sorry. SFLS, did I get that right? Which was it? Consistency equals fluffy. Let's see. So consistency is a var here, and it's defined in the protocol actually as get and set. So we can do that. But shape is read only, is get only. So this is a let, so that's not going to let you change it. But now that the struct is variable, you can. But did you love all the levels of things there are? Shape is non-wavy teardrop. And let's see. I think we're going to get an issue here when I run it. Oh, because I didn't name it right. Naming matters. Mine is really bad right now. Come on. Come on, come on. Come on. Come on. Oh, wow. Did I do that right? Huh. Huh. Interesting. Huh. Huh. Okay. So it's supposed to be a get only. But because I have it declared as a variable, it's not get only. It does conform, and this is what Tia saw on the reverse side. She had a get and set poisonous, but then I told her to use poisonous as a constant, which is get only. Now we have the inverse, where shape, according to the protocol, is get only, but shape is a variable here, so it can be changed. That does conform to the protocol because shape allows you to get it. This particular struct that's conforming to that protocol, you can get the shape, but you can also set the shape. So it's conforming because you have the ability at least to fulfill the requirements of CD. Okay, so it's get, this is get only. The nature of shape as a variable here is you can get it, so that's good. You can also set it. Whereas what we saw before was poisonous is a constant, so you can only get it by its implementation here. If we made it a var, it would not conform to the protocol. How do we feel about that? All right, let's do it from the top. But first, Nima had a question. Yes. Okay, let's start from the very top. So, get and set. Think of them as telling you what to do. One thing might get, when a thing gets, that means that you can view the value. When a thing sets, it means that you can assign the value or reassign the value. You can set the value. So the protocol is saying, hey, you, if you want to be food-like, you have to have a property called poisonous that you can get. You have to have a consistency that you can get and set. You have to have calories that you can get and set. And then there's this function. So if you remember, the function, we only had to tell it what its format should be. So it didn't require anything else of us except that our function fits this format. There's a similar thing going on with the get and set portion of these properties. They are saying, we have no real requirements for you except that for this poisonous thing, for example, it has to be a bool and it must be a get-only property. It's not saying it can't be a get and a set. So long as poisonous has the ability to be read, so long as poisonous is a get property, that's totally fine. Let's run it. Let's get an error somewhere. Cool. Poisonous. Shit. So what we have to think about here, the weird tricky thing is a variable, something you declare as a variable, has both get and set. A constant has only get. So literally by the keywords for our properties in our definitions, we are saying whether something is get or get and set. So poisonous, to conform to the protocol, you must have the ability to get. Declaring that property as a variable does give it the ability to get. It also gives it the ability to set. That doesn't really bear on the protocol's definition, right? The protocol just says you have to have the ability to get. I don't care about anything else about this property except that it's a bool and it has the ability to get. In your implementation, so when you are creating a struct that conforms to this protocol, your implementation gives poisonous the ability to get. It also happens to give it some other behavior, which is the ability to set. So included within the behaviors of this poisonous property is the get that's required to conform to this protocol, and therefore it does conform to the protocol. So think of the real important thing here right now is to think of, in your implementation, a variable as get and set and a constant as get only. So if you want to strictly conform to the protocol for food-like, your poisonous, which is get only in the protocol, should be a constant. But the program is not going to protest you calling it a var because you do fulfill the requirements. It has the ability to get it in your implementation of poisonous as a var. So poisonous is a constant. Let's get rid of that. So let me just review that one more time. In your protocol, you're saying what access you will have to properties. Are they only going to be things you can get, or will they be get and set? You're saying in the way that this is created, you're giving a blueprint. You're not saying specifically what they are, you're giving a blueprint. So if I have a thing called poisonous, so long as I can get it, that's great. Just like if I have a template for, think of like writing a check. A check has a template. There are certain things you have to fill out. You don't have to fill out a memo, but you can add a memo line. It's not required in order to cash a check, but it's something that you can add. So this is just another template that says, I have certain requirements. You can add other stuff. We saw that you can add specific properties for a sunflower seed. You can also add or extend the functionality of this poisonous property. Tia.
If we set it there as false, but then we run the code and put it as true, is it going to reject it or say anything? Does it doesn't match?
So it's going to be totally fine with it just because this property is a var, so I can set it. At this point, like, our specific implementation of poisonous here is the way that we should think about it. So if you see a var, think of that as get and set. The protocol said this should at least get, but since we changed it in our implementation, we're not going to look at how the protocol requested we do it right now, because we implemented it differently. We fulfilled the requirements for it, but we're doing it a little differently. So the definition of sunflower seed is the best place to look for it. If it was a let, then if this is false, we can't change the value later because it's get only or read only.
What if, in your protocol,
Let's try it. In my protocol, if it was a let declarations cannot be computed properties. So it's just not going to let me do that. Let's see if we can do it differently, though. Let poisonous be a bool. Immutable property requirement must be declared as a var with a get specifier. So it's making us do it this way. In a protocol's definition, oh, that's weird. In a protocol's definition, to give it a property, or to say that anything that uses this template will have this property, you use var, so that it can be a computed property, and you can say, this is only for reading, this is only for writing. Or, sorry, this is only for reading, or this is for reading and writing. Michelle.
that would basically,
Okay.
because it's a computer property, it would also be applied.
Because the computed property has to have the flexibility for you to set it. Okay, so if let's make a matrix. Very simple one. No, not in code. Let's make a chart. How's that? Better term. Okay. Okay, so keyword. Read. Write. Okay. So I've got a keyword that's get. Can I read it?
Yes.
Can I write it?
No.
Cool. So I've got keywords that are get, set. Can I read it?
Yes.
Can I write it?
Yes.
Sweet. If I've got a keyword that is var, can I read it?
Yes.
Neato. Can I write it?
Yes.
All right, last one. So I've got a keyword that's let. Can I read it?
Yes.
Can I write it?
No.
All right, if I've got a keyword const. Is it a dot? What do you think, though? This is a constant. It's in JavaScript.
You can read it.
So you can read it. You can't write it. This is something that isn't just for Swift. It's for all other programming languages. So when we talk about read and write, this is the pattern we can look at. When you see it in another language, this is what they're talking about. It's the ability to get a value versus changing the value. I'm going to take a picture of this. I think it's just as beautiful as that. So I have this little slide.
Sign it.
Sign it.
Yeah.
Thank you.
Put a pomegranate on it.
What?
Put a pomegranate
I don't know how to draw.
on it. Okay, just one. Remember to take it too, so you can always remember.
Very
Cool. Okay.
Cool.
All right, what are some questions about getting and setting?
What's that?
What are some questions about getting and setting? I'll hear them all. Can I please?
Give me a real life.
Give you a real life example. Ram had a really good one. Arrays. So arrays, is that not real life enough? Okay.
Like an actor, like
What's a real life example of
like
get?
I mean with the protocols that we already have. Can you
I'm not sure what you're asking. Sorry.
Would you be so kind to please write a code
Yes.
with the codes that we already have using? Yes.
Okay. Here they are.
But don't tell me.
Here they are. So, no. So what I'm saying is get and set here are going to tell you that you can, if you have something that is get and set, it means that when you implement this protocol and you declare that property, if it's get and set, it has to be a variable because that's the only one of those key words for storing a value that allows you to get and set. So I've outlined that in my protocol, and now in order to implement it, I have to have a var here. If I have a let, it's not going to fulfill the template of being able to get and set. If I have a get only, so a read only, it's not going to strictly require that my property is get only. It's just going to say, as long as I can get this thing, so it could be get only or it could be get and set, as long as I can get this thing, you conform. That's cool. You're implementing me the right way.
So then you also set.
Exactly. So we can change in our implementation of, what is that? Of food-like. In this implementation of food-like in sunflower seed, we can set poisonous. But we're not strictly conforming to the protocol. So again, we said like you would use a protocol when you want things to have specific behaviors. And this is kind of loosey-goosey because now we're saying, oh, it can be poisonous just like food-like, but it can also be poisonous in our specific way. So there's kind of like an overlap of purposes here, right? So I would only use the protocol food-like if I want to implement it in the specific ways that that protocol outlines. So this is acceptable in code, but in future, if you go to use this protocol, it might be a little ambiguous as to why you specifically made this change for sunflower seed. It might be weird as to why you can change the poisonous value of an instance of a type. So the template, the blueprint, the protocol here is saying, when you have something that's a food, something that's food-like, you want to know if it's poisonous. You want to be able to see that info. According to my definition of food-like things, no one can go ahead and change that value. So once we know, we know. Once it's set, it's set. And that's why it would be set only. For our implementation, to do that in like a human readable way, not something that'll create an error, but something that makes logical sense, we would implement it in the way that the protocol asks us to. It's not required that we do that because we fulfill the requirements by at least having a get using a var. Bam. So there is a get. So we are able to get. That's cool. But this can also set, so it's working a little differently than, say God created food like God wanted it to be used a little differently. What?
It's for God.
Yeah. Welcome to Temple. Okay. What? What did I do? Oh, sorry. I just cracked my. I just cracked my hip. Sorry, what? I mean, not wrong, but I don't want to get that on tape. So you could just, you know. Okay. Okay. So I want you all, before the first protocol I showed you was blah, 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 fully named. I want you to change this up. Give it a couple properties that indicate that when implemented, make up each part of the name. So a couple different strings is what I mean. And shut up. Let's comment on this. Great. And an instance method that will return the full name as a string. So I want you to give me the blueprint for that, and then create a struct called person that conforms to the protocol fully named. And so you'll have to implement, right? You'll have to conform to the protocol in your implementation of this struct. Do we level those words? Is there anything I can clear up before you have 11 minutes to do this?
Yeah, I'm fully named because we're going to create properties that make up the name. Don't need property full name.
Change this up by getting rid of full name. Cool. All right. just celebrating. No, you're gonna see how we use this much more tomorrow, and you're really gonna. Sorry. Sorry. Oh, man. Tired. Bless you. When you're having fun, Ava, that's when it flies. Who's the person thinking about the Illuminati? I don't think I quite parsed this. Is it Sunny?
No. God said draw something cryptic.
Alright,
It's the Illuminati.
fair.
That would add up yesterday. Somebody right when we're looking at the Latin words and all of that. When we were looking at like the meaning of the Latin message that comes by default in text. It would add up, right?
have to either get or get that, right? Yeah, exactly. So that's the whole thing. It's kind of weird, but like you have literally get you could basically do whatever like yeah, it's just sort of like like yeah, you could make that. Yeah, getters that only work for properties. They don't work for like. Yeah. Yeah. You could call on it, but you can. Like. Can't say it's right now. You can get it, but yeah.
Well, good for her. That's awesome. When did she start?
Next Monday. They gave her the offer.
Your group is so strong.
I know. So initially, it was the custom groups of, I don't know if you know this, of like teams of 3. And it was just like me, Jane, and Yvonne. And Ellie was like a team with Jose and I don't know who else. And then I think like 2 days later I came in late and like Ellie was in the meeting. And I was like, okay, so hi Ellie. And she was just like, oh, what are we doing? And I was like, oh, you're so interested or trying. She was like, no, now I'm in this group. I was like, oh shit, I didn't realize.
What did they do? Instruction to that group. Fell on his face. Was she like, is that like they reorganized after that?
I think so. Yeah. But the way they want
Some good discipline.
I know, right? Very yeah.
Oh, yeah, but you have to work. all the classes together, like it's by definition or adults. Only if it's allowed. Oh no, it will matter. If you were to make one of these products, then you would have to follow up on what you're going to do.
Did you have brother citations of, or your brother citations?
Yes. So, I never used so like, if I want to this one, then we'll talk again.
Right. Yeah, I think. You're pretty used to protocol all the time, but like, you're just like gonna make it fun, you know what? Like, you're not, like, you can go super deep into it, like, on the dinner. Most of the time, it's just like, alright, it works. Yeah, exactly. Yeah, it's only reading. Yeah, all those things. Yeah, you can also see.
For myself, I
Hi. Are you okay? Okay. Okay. All right. Okay. B, I love it. It's really good. Okay. Who would like to code this for us? Sam would. Sam did this morning. Unless you would like to. Would you like to do it?
They like Albert definitely would.
Have you? Who has not been up here before? Aaron. Oh.
Aaron has,
It's nice of you to volunteer. Hold on. What about Jason? Have you been up here before? Okay. Eric? Okay. Kevin. Yeah, Kevin. I love that. Let's pay attention to what Kevin is doing. He says as he opens his phone. Can you tell us what you've done so far? Guys, give me attention to Kevin.
So I made the protocol fully named with 3 variables: first name, middle name, and last name, and then the empty function, which I will call in the person struct right here.
That empty function, there's a fancy name for it that I've never used before, so I'm not correcting you, I just didn't say it. It's called the function signature. Think of it like the format of the function. Function
Wait, what
signature.
is that called?
The function signature.
That's only in
No, it's basically the format of the function. So if you notice when you pull up the function, it tells you, here's my arguments, here's my return, here's my name. Like that whole thing is its signature. The name, the arguments, so the inputs, and then the output of the return. It's its signature. It's an incredibly anonymous person. Awesome. It's running. Let's see. Sorry, my computer is slow. It's these two arrows. Let's see what those arrows are. Extra argument.
Ah.
Okay. If you can just pull out the argument poise out. Yeah, you can just. Okay. All right.
Screw all of that.
Fair enough.
Oh,
Hold on, just Control Z it.
yeah.
Okay. You can just, yeah. No, just go to the part. Okay. Okay. Sorry, I trust you.
What now?
Let's see what it says. Type person does not conform to protocol fully named. So let's look up full name. Interesting.
Let's type some.
Stuff. Let's see what it says when you try to fix it. Press the stop sign. You want to add protocol stubs. I don't know what that is. Oh, okay. Interesting.
Oh, it's because I think his full name has a capital.
Oh wow.
Oh,
The other case
is it named differently?
capital.
No, it's the opposite. There's a lowercase n in the function signature,
Yeah.
so it's like you didn't do exactly what I wanted you to do.
Yeah.
See how helpful arrows are?
Now we're good.
Okay. All right, let's give Kevin a round of applause. Awesome. Do you mind if I talk through your work? Okay. No, you don't mind. Cool. Okay. So Kevin. Okay. Nil. So this is not optional. So it's not going to accept nil as the proper argument. Right? This is a string. We can make it a string. Let's do that in just a sec. I think that's actually a good idea. we've got a protocol called fully named. So what we're saying is things that conform to fully named can have a first name, a middle name, and a last name. And there's a function we can call that will return a string that is their full name. So we are just giving the format, the blueprint, the template for how anything that's fully named will operate. Then we decided, here's a person. A person is going to be fully named. So that means a person will have a first name, a middle name, and a last name. And then they'll have a function called full name that returns a string. For a person, you will return, for a person, you'll return first, middle, and last if there's a middle name that's not an empty string. Otherwise, you will return first and last. Cool. Tia had a question. Why can't middle name be nil? So we're going to get a compile time error if we try to make middle name nil because it expects a string. It doesn't expect no string. It expects at least an empty string. It expects something of type string. Nil is not type string. But I think I get where you're coming from. What's that? I think I understand. So let's talk about it in English. Someone might not have a middle name. So we might make middle name optional. And now I'm being told this person doesn't conform to the protocol middle name. So if I make it optional, they'll be cool with it. Then they're going to say, okay, something weird is going on. I'm not using optionals in the right way. What's a way that I can check if an optional has a value? Kimball. If let, what do we call that? Different one. Optional binding. So what we do with optional binding, again, is we say, all right, if there's the case that this middle name, and to clarify, bound middle name, or let's say binded middle name. I don't think we practice enough with optionals, but I think you're beginning to see how valuable they are. So if this middle name has a value, so if it's not nil, if there's a value inside of that optional, use this constant as that value. So middle name is an optional string, binded middle name is a string. So these are different. This line is saying in the hypothetical case that middle name has a value, use that value, and you can use it in this block of code here. So we'll say use some optional binding, do that, that's great. Awesome. So this also conforms to its prototype. Its prototype is a little different than the one that Kevin made. That's cool. Let's talk let's start that sentence over. Let's talk on a slightly higher level about all these things. I like Kevin's setup. You might have had maybe first, middle, or last name as get only, and that's totally fine as well. When you make a decision with your code, you should be prepared to explain why you did it. So I like these as get set because someone can change their names. I'm not going to make them get only because I think that people should be allowed to change their names. If you want to make an argument in the other direction, you could just make them get only. So that if you can explain in plain English why you're doing that, you can call it a design decision or just explain your decision, then I think people will be amenable to what you're doing. If it doesn't work right, that's another situation. So if later on you have to use a person and you're going to change their name, their first, middle, or last name, you're going to need it to be a get set. But in our current example, we don't have those requirements. We're not doing anything with our person yet. So I'm going to make it get set, and I'm going to say that's how this works until maybe I need to change it later. And the thing is, it's code, so it's not even like you have to erase anything. You just press backspace and you've changed it. Down here? Cool. And then Rod had one other thing that she did. So in our struct, it might be the case that we want people to, let's make an instance of this struct. So we've got person1 is equal to a person, and then when I go to initialize a struct, it says, you have to give me all the values I don't have. So I've got John. Let's say John again has no middle name. This is an optional string. It's a little weird to, feed the value nil in there. It's kind of weird. You're just saying, for this value, middle name, don't give it, for this property, middle name, don't give it a value. It's like a weird way of doing things. So what you can do is, if you remember, classes required you to have an init function. You had to tell it how it's going to get its properties that don't have default values. For a struct, you're not required to create init functions, but you might create multiple init functions just so that you can create an instance of this struct in multiple different ways. So let's say here's an init that leaves out the middle name. So I'm going to say self.firstName is equal to first name. Self.lastName is equal to last name. This specific init function has a specific job. Just like, let me see if I have it. Yep. So just like, if you remember, I'm going to delete this after, but when you're initializing a UI color, these are all different initializer functions. You're outlining, you're giving different information for each of these initializers, and then within the definition of UI color, it knows how to handle the information that you give it, and then give the initializing properties to an instance of UI color. This is all we're doing, and I'll show you in just a second. So this specific init function handles creating a name that doesn't have a middle name. I'm going to get an error if I copy and paste the same exact function signature. So if I create an init function with those two same arguments, it's going to say, you already did that, try something new. This one is going to have the ability to give a middle name, give person a middle name. So we'll have self.firstName is first name, self.middle name is middle name, self.lastName is last name. So what we're doing here is we're building in the ability for a user to decide whether they want to give their person a middle name. Let's see what that looks like. So again, just to show the example from before, a UI color, when I initialize it, has a bunch of different ways I can initialize it. I see all these things. Cool. Sounds good to me. In the same way, the person now has two different initializers. So I'm going to make John Doe, John, first name, last name, Doe. I can also make Lon person 2 John, I don't know if you knew, but it's just this middle initial, A-C. So this person has a middle name, the other person doesn't. They're both totally valid because the value of middle name, the type of middle name is an optional string. So I don't have to set that string. But if I don't have a custom initializer, my struct is going to say, all right, you didn't give any properties for all these, so please give them to me. If you create these custom initializers, then you'll have the opportunity to initialize in multiple ways, in the ways that you want. You make it much more, you make the code much more friendly for other people. We're learning so much about making flexible code today, right? We're learning all about how you can just make code so much easier for everyone to use. I think it's cool. Ayula, do you still like protocols from this morning? Okay. Just checking in. Okay, cool. So, what are some questions you have about protocols? Because I think that's all the stuff I have to tell you about protocols. Phoenix.
A lot uses some other protocols that are like big things to do like equitable fairness.
Yeah. Let's look at them. So there's a bunch of protocols that are built into a lot of things that you already use. Here's your list. So we've got equatable, we've got comparable, we've got hashable, we've got collection sequence, custom string convertible. These are all super important. They say, first of all, let's look at the way that they're phrased. Equatable. It's saying you have the ability to equate something, right? That naming is super helpful. It says this protocol can be conformed to by making things that are equatable. We're gonna sit equatable out right now. Yeah, we're gonna sit it out. It's kind of very important, Comparable or comparable literally means can some type conforming to this protocol compare to other instances of that type. So if you conform to comparable, that means that you can be compared. You can check for equivalence, you can check greater than or less than, greater than or equal to, or less than or equal to. So in your implementation of that type that conforms to comparable, you have to outline how those comparisons work. So you could do something really wacky where, so let's think about comparable again. Let's think about comparable right now, actually. I'm going to look up the protocol for comparable Swift. It says how to conform. It allows you to use the less than, greater than, less than or equal to, or greater than or equal to, with conforming data, which in turn means that Swift knows how to. Oh my God, this UI is terrible. What's going on? What is going on? What the fuck? Sorry. Whoa. Thank you. My computer is very angry. We're going to go away from that. Let's just look at the documentation. Oh, my computer is... Oh. Oh. Okay, let's do it in here. So, comparable is just the protocol. So, person can be comparable if it conforms to the protocol. Let's see the protocol stubs. Let's see what's required to be comparable. Oh, I just need to define what less than means. I just need to define what less than means by taking two instances of a person and then returning a bool. Left-hand side means it just means first thing being compared to the other thing being compared. You can define anything in here. So you can try to look at left-hand side dot first name and then look at the like first character or something, and then see if that's greater than the right-hand side's last character, first name's last character, I don't know, see that, and then return that comparison. That's great. You could do all that. You could make that work in a certain way. You could also, well, what the fuck, bro? Come on. All right. Say I knew how to use characters. That could work. You could also conform to this protocol just by returning true. So all this means is like I created a meaningless function here. It just means anytime you compare left to right, it doesn't even look at whether left and right, it doesn't do anything with left and right, but it does return true. So it conforms to the protocol by having a function that takes in 2 arguments and returns a bool. It returns a bool. Doesn't do anything with the arguments, doesn't do anything to calculate the bool, but I have conformed to the protocol by having a function that takes in these 2 arguments and returns a bool. This is very literal and stupid, and obviously you wouldn't use it, but that's all conforming to a protocol means. It just means you implement what the protocol requires you to have implemented. So I could go back, I could return just a comparison of first name and last name, first name and first name between them. You could do anything so long as it returns a bool. So you could say, I want to be able to compare people by var, you know, this is America, right? Var net worth is equal to, is an int, and then your comparison, so saying if someone's greater than the other one is, you just compare the net worth, right? That's cynical. But that's making our function conform to the comparable protocol. That's it. That's all we had to do. All you need to do for comparable is all you need to do to conform to comparable is implement this one type method, right? That's what static means. You just need to be able to compare a person and a person in order for a person to be comparable. Yep. So this protocol, let's look at it. Comparable. Returns a Boolean value indicating whether the value of the first argument is less than that of the second argument. It's the only requirement, that function is the only requirement of the protocol. The remainder of, the relational operator functions are implemented by the standard library for, any type that conforms to comparable. It's saying that if you give me less than, I can do the opposite for greater than, and I can figure out less than or greater than or greater than. If you give me less than, I'm so out of words. If you give me less than, I can give you greater than, because I can just do the reverse. I can give you greater than or equal to, and I can give you less than or equal to, because those are just using the logic of less than in reverse, or combining them with equatable. Ask me that again, sorry. Yeah. It's not that it works for them. It's if we want to, we would choose this protocol if we wanted to be able to do those comparisons. So right now, if I didn't make this struct conform to comparable, Go away, int. Go away, go away, go away, go away. And I tried to compare person 1 and person 2. Binary option cannot be applied to these two person operands because greater than or less than or greater than or equal to or less than or equal to are functionality that you get from the comparable protocol. So because I've defined my person without telling it how it can be compared or how I can use those comparison symbols, then it doesn't know what to do with this. It doesn't know how to compare them. And so when I implement the protocol comparable, I'm literally saying, okay, I have to outline for you how you will compare things of this type. Just non-self network. It's just me talking about me. Student loans. Very good. Cool. Cool. Okay. So that is one protocol that you've seen behind the scenes all the time. Strings implement the protocol comparable because you can compare them. And if you remember, I have no clue how those strings are compared. Let's go take a look. Let's look at the definition of a string. Public struct string. Initializing a string with an empty literal. Let's see. Does it implement comparable at all? Ooh, what is that? What is that? Ooh. Is this all within string? Look how long string's definition is. How many more we got? 535 matches. Okay, I challenge you to find, oh, look at that. It implements greater than. It returns a Boolean value indicating whether the value of the first argument is less than or equal to that of the second argument. This is the default implementation of the less than or equal to operator for any type. Oh, sorry. The comments refer to the functions below them. The parameters, left-hand side, a value to compare. Right-hand side, another value to compare. So actually, it doesn't look like strings conform to comparable, but they implement everything in comparable on their own. And I think most of your like built-in types, like doubles and ints, might do something similar to this rather than using the protocol because they need to like be so solid and have all their information. Also, I was just wrong about how this works. Was I? I think I was. I hate being wrong, but so anyway, it implements, string has to implement something like that. It's not just perfect out of the box. Strings have to be defined as well. They have to tell you how to use them. Go back. So you've seen comparable before. It's cool. Hashable, it's a way of looking through a unique set of items. Maybe like keys in a dictionary, maybe like a set. So hashable means that things of this type can be looked at for uniqueness. Just think of it that way. Collection, sequence, I will let you worry about both of those. Custom string convertible, I want to talk about a tiny bit. Oh, let's make our person conform to custom string convertible. Look how our person's growing and look how ugly it's getting. And remember what we did with our Swift style guide before. There's a way we can make this prettier. Custom string convertible. All right. Now I'm going to get a very helpful error, right? This is actually really helpful. This error keeps telling me, listen, I'll tell you what you need to do, just do it. Great. So all it does is say, I need a description. That's it. This description in my struct could be a computed value. Maybe it just needs to be read. First name plus 1. Description. Oh, let's see. What can we do with description? Description, let's look at it. Person, we've got a person, and then let's say I go, I print person 1. Are you ready for this? It's about to get wild. Hold on. It'll be fine. It'll be fine. Give it like 3 hours. It'll be fine. This is not working. That's dead. Come on. So I printed out person 1 for any type. This is fucked up. Like, for any type that conforms to custom string convertible, it must have at least a get property called description. So to conform, it must be called description. And this description property is literally what's going to be printed when you use the print function. So you are outlining to the computer what it's going to print when you print a person. You didn't go and look at the property, this person's first name. Instead, it just went into description and said, print this out. If we didn't have it conform to custom string convertible, and we print out person 1 like we're doing below, let's see what it does. It just prints out a thing with all the properties in it. So you can customize what's being printed for your type, what information is being printed for your type, by making it conform to the protocol custom string convertible. That's crazy. Rod. Because maybe you want things to print it a specific way. So, but maybe you wanted to literally just print the string, my first name is John, when you print a person. And so we would say, let me add it back. Come on. Return my first name is first name. Now, when I go and I print this person, so I want a person to work in this specific way, I'm saying, whenever you print a person, just tell me my first name is and the first name of that person. So, yeah. It's crazy. Now you're getting into like the guts of how Swift is actually constructed. Protocols pass around all this behavior and properties to other things. So this delegate pattern is how you can, this custom string convertible is how you use the delegate pattern to print out all sorts of things.
So would you have to manually go into your code behavior and turn on different?
Yes. So you might not make it conform to custom string convertible, and you might be fine with it just printing out that like tuple called person, and then in parens all the properties. You might be fine with that, but you might also find that when you print an instance of a person, you want it to print particular things. It mu- yeah. What about this? Instead of having a full name function, so let's say we went back to fully named. In here, we had it do that stuff. Cool. All right. Istishna, what's going on, bud?
Really quickly, I know I've moved some ones for this week and next week. Please check your calendars to make sure that all the things should be on your calendar as well. And I'm going to do one on the now. This is a good time for
I mean, I don't want to talk to them anymore. Yes. So I didn't finish my pairing app, so we're going to use the old pairing app. I'm really sorry. Feeling bashful. Let me run pairs, and then after that, it's lab. Cool. We'll come back at 5:30 for questions and to do one of the parts of the lab. Protocols are cool. They're really cool. This is David signing off saying protocols are cool.